Good afternoon, class. Today we're going to solve quadratic equations. We sort of began this the last time when we were factoring, so I better switch over to my paper. I need to do a little writing first before we start doing any of the examples. We're going to see three methods of solving quadratic equations today. There are four methods that are generally accepted, but that fourth method, completing the square, we'll wait to look at until we get to circles. I like introducing completing the square with circles rather than quadratic equations. So I'll say we're going to look at three methods of solving a quadratic equation. Ax squared plus bx plus c equals 0. We've already seen the first method. That was what we were doing there at the end of class on Wednesday. I think I'll Roman numeral these three methods. The first method, Roman numeral 1, by factoring, that zero factor property. And if we're going to solve an equation by factoring, we need factored form on one side. We need the expression factored on one side and set equal to 0 on the other side. And I know we did some examples involving solving equations by factoring the last time. And let's look at number 3 to get started, just to remember what we were doing. Every year I think, I'm going to move number 3 up to number 1, and I never do. It's the easiest problem in the assignment. I should have it as number 1, because look at that problem. It's already in the desired form. We have parentheses. Notice it's already factored on the left. And on the right, we have it set equal to 0. So they've done all the work for us. They've already factored the expression. Let me write this down. This is number 3. 11r plus 9 times 2r minus 6 is equal to 0. I want you to notice something here. It's a good thing the instructions don't say to factor the expression, because this wouldn't be counted correct as factoring. Look at these factors. There's something wrong with one of those factors. The way we factor, it's called factoring completely. There's something wrong with one of those factors. Remember, we said inside the parentheses, you can't have a common factor other than 1. 11 and 9. What's the only number that divides evenly into 11 and 9? 1. But what about 2r minus 6? 2 and 6. Those are two even numbers. Is that okay? No, it is not. But we don't have to worry about it because they've already factored. They've factored it like that. To solve the equation, we just set the two factors equal to 0. 11r plus 9 equals 0, and 2r minus 6, set that one to 0 also. Remember, we said the last time the only way a product can equal 0 is for one or more of the factors to be 0. So when is 11r plus 9 equal to 0? When is 2r minus 6 equal to 0? Solving this first equation, you tell me what I should do. To solve this, there's only one correct next step. What is it? Okay, so we're subtracting the 9. Minus 9, that gives us 11r equals a negative 9. And then
divide by 11.
Divide by 11. So there's my first answer. Realize 11 divided by 11 just gives me 1r equals negative 9 over 11. And so negative 9 over 11 is my first answer. The second one, to solve this second equation, what will I do first? So I need to get rid of that minus 6 by adding 6. Remember I mentioned transposing the last time. If you have a term there that's added or subtracted to get it to the other side, you can just think of picking it up, move it over, change the sign. Isn't that what happens when you do plus 6 plus 6? 0 plus 6 gives you a positive 6. And then divide by 2. The 2's cancel, leaving us r equals 6 divided by 2 is 3. So for the two answers that I have negative 9 over 11 and positive 3. So we switch back to my lab. And notice they've already written the r equals. So all we need is negative 9. And I'm not even using the hot button here this time. If you're just punching in number over number, you can just use that little slash on your keyboard. And notice they say to separate the solutions with a comma, but do not put the comma in the denominator. As I warned you, occasionally they'll forgive you and they'll accept that comma in the denominator, but under most instances, they count it wrong. So do your right arrow, then put your comma, and what was the other one, 3? Any questions there? That really should have been number 1. And I'll make a mental note to myself next semester when I'm setting these courses up, put that at number 1, but I'll never remember. 3y squared plus 16y plus 13 is equal to 0. And the instructions say to solve by factoring. Let me make sure I didn't miscopy the question. No, that looks right. Come back over here. If we're going to solve by factoring, remember the terms need to be in descending order. X squared, x, and a constant, that's what we have here. So, and we have 0 on the other side, so it's ready for us to try to factor it. I'll write my 2 sets of parentheses. Hey, this isn't that bad. The last sign's a plus. What does that tell us about the signs we need inside the parentheses? Okay, if the last sign is plus, you have 2 of the first signs, plus and plus. For 3y squared, what times what will give you 3? 1 times 3, so I'll think of it as 1y times 3y. What about 13? What times what's going to give me 13? Once again, that's not too bad. There's only one pair that I can think of. 1 times 13. 13 is prime, so I'm going to write down the 1y plus 3y. And after doing this stuff for, well, at this school, this is my 36th year here, and there was a year at Baylor, and then our time at Stephen F. Austin, so it made more like, what, 39 years? But somewhere along the way, I just made the habit. For the first term, I always put the small coefficient and then the big coefficient. I had someone in my online class that watched the videos wanting to know, could they have put the 3y and then the 1y? Yes, multiplication is commutative. It's just my preference to go small to big. Now for 13, I know one thing. I can play it out in my head right here without even writing down anything. If I put the 13 here, remember the outer and the inner have to add up to give you that middle number. You put that 13 there. 13 times 3 is what? 39. That's way too big to give us a 16. So if this is factorable, the 13 can't possibly go there. We'll have to use the 1 there and the 13 there. It's not touch screen time. Oh, okay. Oh, so y'all want to check? Let's check the outer product. What's the outer product? Y times 13, that's 13y. What's the inner product? You tell me. 3y, that's a positive 13y and a positive 3y. That gives me a positive 16y. Is that what I needed? Yes. And now that it's factored, then we set each factor equal to 0. Set y plus 1 equal to 0. Set 3y plus 13 equal to 0. Setting y plus 1 equal to 0, that says y is equal to what? Negative. Remember, you pick it up, you move it over, or you do minus 1, either way, you get a negative 1. There's my first solution. The next one, what will I do first? Subtract the 13 to give me 3y equals a negative 13. And then what? Divide by 3. Divide by 3 to give us y equals a negative 13 over 3. Can we reduce that? No, they're both prime numbers, nothing to reduce. I guess you might think a mixed number, but in algebra you rarely ever use a mixed number. In other math classes, you may have been told if you have a fraction, you got to rewrite it as a mixed number, but not from an algebra class, mixed numbers are very undesirable. So let's type in our answer, negative 1, comma, and then the fraction negative 13 over 3. Oh, wait. You'll notice if you wanted to type it in as a mixed number, what would that be? 3 goes into 13 4 times, remainder 1, so negative 4 1/3. They do have a little mixed number hot button here, which I have never used, okay? So my advice to you, don't use that
And it's not
mixed number hot button. I know it's not there always anyway. Any questions?
Would they accept it if you put 4?
Yes, they would. Yes, if they have the mixed number hot button there for you, they will accept it. If they do not, and you type a negative 4 and then try to put in the little fraction bar, it's going to assume negative 4 times 1/3, and they will not. So that's why I say don't even get started with mixed numbers.
Okay.
Roman numeral 2, switch back. We have to do some writing.
Okay. Factoring.
Okay, factoring was the first method. I said we're going to do 3 methods. I think I'll use green now. Roman numeral 2. The square root method.
Yeah.
Okay. The square root method. The square root method, if you understand what it's saying, it's obvious, okay? If you have some quantity squared, I'm going to use a capital X squared is equal to n, where n is a number, then the thing that's being squared has to equal the positive or negative square root of that number.
X squared is 25.
You know, I think that's the one I always use to make
49.
up. Yeah, that's what I was going to change it to. X squared equals 49.
I think
They're
even
without this, you can help me figure this out. What numbers can you square to give yourself 49? 49 is a perfect square. What number squared gives you 49? There are two of them. Okay, I heard one of them, 7. I'm assuming you mean a positive 7, right? Okay, so I put down a positive 7. What else can you square to give yourself 49? A negative 7. That's what this thing is saying there. You take the square root of the number, the square root of 49 is 7, and you want both the positive and negative of it. So x has to equal either positive or negative 7. Any questions with my logic there? As long as your equation is in the form something a quantity squared equals a number. You can't have an x over here on the right hand side. You have to have the variable quantity squared on one side, a number by itself on the other. Question?
What you're saying is that the x to the equals to 49.
Oh, I can't hear you.
Sorry. So what you're saying is that the x to that equals to 49 could be either a positive 7 or a negative 7.
That's right, because positive 7 times positive 7 gives you 49. Negative 7 times negative 7 still gives you a positive 49.
Because negative times negative is
still
always positive.
And with that in mind, let's look at number 4.
Oh.
We have the equation 5x squared is equal to 10.
Oh.
Well, 5x squared is equal to 10. And the instructions just say to solve the equation. They don't specify a method, but if you can get the equation in the form something squared equals a number, and we have a number by itself already on the right hand side. So I'm thinking that square root method is a good approach. But what's being squared here? Look at that little square. What's the base of that exponent? I guess the real question I'm asking, is 5 being squared also, or just the x being squared? What's being squared? Just the x. If you wanted that 5 to be squared also, the problem would have to be written like this. You'd have to have the 5 and the x in the parentheses. But as it is, the 5 is not in the parentheses. It is not being squared. We can get it in the form something squared equals a number just by dividing by 5. Then this equation is tailor-made for the square root method. 5 divided by 5, that cancels, leaving us just that x squared, and 10 divided by 5 is 2. It's in the form something squared equals a number. When you have it in that form, you drop the square on the left, you pick up a plus or minus square root on the right. You drop the square on the left, pick up a plus minus square root on the right. Can you reduce the square root of 2? Y'all, no? Okay. Y'all are so quiet today. I think you're tired from the weekend, maybe. Oh, to be young again. I remember Mr. Strickland telling us it was a Monday. It was our first semester teaching here, and we were exhausted. Mr. Strickland, at this point, I think, was the most senior math teacher in the state of Texas. He'd been at Delmar that long, and I was yawning on a Monday, and he was like, oh, that's how you tell the old teachers from the young teachers. The old teachers are tired on Friday, the young ones are tired on Monday. And at the time, I didn't really appreciate his wisdom. Now I know. Yeah, here I am on Monday. I'm so well rested. By Friday, I'm going to feel ridden hard and put away wet.
But you couldn't simplify square root of 2, so you just leave it as plus minus square root of 2.
Show them how to punch that in. I remember When I remember the first time clicking there, click the box, look at the toolbar. Do you see what they've added? I remember the first time they put in the plus minus hot button. Tony and I had been asking them to do that for a while. And
Because before then you had to write
right, square root of 2,
comma,
negative square root of 2. But now with the hot button, I was just ashamed to admit how excited I was. A
You were
colleague
old back
said
then,
that,
too.
I was, I know, but a colleague of mine said it didn't take much for me to get excited. We were running around telling everyone they put in the plus minus hot button. They didn't seem excited, but I was, and you should be too. Every time as we get messy fractions with a plus minus, and we're going to have them, you'd have to type it in twice. What's with the plus and what's with the minus? You'll see what I'm saying.
And I believe they still do that if you get it wrong and it tells you the correct answer.
Yes.
Like if we had gotten this one wrong and it gave us the correct answer, it would say square root of 2, comma, negative square root of 2. They still haven't taken into consideration that there's a plus minus key
button.
there.
But I think it was the twins, Tim and Tony complaining. That's what made our Pearson rep had to tell the programmers, oh, come on. I'm tired of listening to complain about wanting a hot button, a plus minus hot button. So can't y'all program that? I know all the programming used to be done in-house here in the U.S. I don't know if it still is. We used to know one of the programmers.
And then
She loved her job, and then
she got sick, and Pearson had to do what they had to do. Let her go.
Yeah.
Don't
be recording.
Oh. I'm just joking.
Well, yeah.
Oh,
okay. Don't say anything bad about Pearson. They'll give us bad numbers and the problems. Have y'all written it down for it? Okay. Let's switch back. Oh, goodness.
I think
there's a problem here. This does not look like a square root problem. If it's a square root method problem, you need something squared. I'm going to write it like this. Something squared equals a number. That's what we want. Something squared equals a number. Well, what's the only thing that's being squared here? The x, so we got to get rid of the 4, we got to get rid of that 20. We want the x squared by itself, and we want the number by itself over on the right-hand side. I'll get us started. Let's move that 20 over by subtracting 20. That'll give us 4x squared is equal to negative 20. And
now
then,
it's sort of like number 4.
Now it's sort of like number 4, but can we leave that 4 there? No, what are we going to have to do? Divide by 4. 4 is not being squared, so that gives me x squared. Negative 20 divided by 4 gives me a negative 5. And now I claim we have it in the order that we want. We're able to get well, you tell me. We're going to drop the square on the left. We pick up a plus minus square root of negative 5.
Make that negative maybe blue or something, a different color.
I'll use purple.
That's this negative here.
Oh, I made both of them the same color. Well, oops. Okay, I'll do it like this. There. And if you type that in, 5, you can't reduce the square root of 5. If you type that in, though, they're going to give you an error. What do we have to do? The square root of a negative. What was the stuff we were doing on the second day of class? If you see a negative number under a square root, you have to rewrite it using what? I. Good. So you're going to have a plus or minus. Since it's negative, I bring out an I. I'm going to leave the 5 under the square root. For plus or minus, I square roots of 5. when we're factoring quadratic expressions, we don't get imaginary solutions because you don't wind up with x squares inside the parentheses and taking square roots and negatives. But the square root method, it can give you imaginary solutions as well as real solutions. So that's one thing that's nice. We're able to get an imaginary solution for this question on number 5. Any questions on my logic before we type in the answer? Do not forget what we've already learned. If you have a negative number under a square root, you're going to have to rewrite it using I.
Like if we had what I was going for when I started talking about the colors.
I'll do it.
Okay.
Okay. The square root of negative, well, those colors they don't look any different to me, Tony.
Yeah.
So can y'all tell that those are 3 different colors? That negative becomes the I. The square root
Just keeps the 5.
just keeps the 5.
And you still have that red plus minus.
And you still have the plus minus, okay?
Yeah.
But it's that minus that was under the square root. That's why we had to stick on that I. Any questions there? As long as the equation is in the form quantity squared equals a number.
That quantity could be just a variable.
It may be a messy step, but as long as everything on the left side is being squared and you have just a number by itself on the right-hand side, then you can use the square root method. Did you type in that answer?
No.
Go ahead and type in that answer.
Okay. I'm going to show y'all what I mean about if you, before the plus minus key, you had to type it like this. I, square root of 5,
Get
get
out.
out from under there and put a comma, then a negative I, square root of 5. The reason I'm writing it like this is also, if we had gotten it wrong, it's going to write it like this is the correct answer. And sometimes students say, oh, wow, it counted it wrong because I put plus minus. No, it didn't. It counted it wrong for something else. Okay? It doesn't count it wrong for using the plus minus key. Okay? I'll tell you what might count it wrong. If this comma were under that square root, it's going to count it wrong.
Mm-hmm.
Mm-hmm. Number 6. Oh, we have multiple choice.
Okay, let me write it down. Let's see. A 3x minus 2 quantity squared is equal to, is that 23?
Mm-hmm.
So 3x minus 2.
I'll hide the answers.
Do that. Switch it over. There. Remember what I wrote down here at the bottom of this page. As long as the equation's in the form a quantity squared equals a number, you can use the square root method. If this problem here had a 23x on it, you could have used the square root method, but I claim the way it's written, it's in the desired form. We have a quantity being squared, and we have a number by itself on the other side. So according to the square root property, you drop the square on the left, and what are you going to have to pick up on the right?
A red.
What am I going to write in red now? When you drop the square on the left, what do you, a plus or minus, keep going, and a square root on the right. You drop the square on the left, you pick up a positive and negative square root on the right. Am I going to have an I in my final answer? No, because that number under the square root is not negative. Can we reduce the square root of 23? Is 23 a perfect square? No, 23 is prime. You're not going to be able to reduce the square root of 23, but we still need x by itself. So just ignore that plus minus. Pretend it was just a plus or a minus, okay? I want the x by itself. There's only one correct first step to get that x by itself. What is it? Add 2. Okay, so we have 3x equals, I'm going to take that thing that doesn't have a square root, that 2, I'm going to put it in front of the plus minus. So that'll become a positive 2 plus or minus the square root of 23. All I did was pick up that 2, move it over, make it a positive 2. Or you can think add 2, add 2. Either way, you'll get to this step. Then what do we do? I couldn't hear you. Divide
Yep.
by 3.
I heard.
They know I'm hard of hearing. And they know not to laugh because they'll be the same way one day. So we have x equals. So we have a 2. Hey, this is multiple choice. Let's look and see. Maybe we'll get lucky. Maybe this is one of the possible answers. Let's see. Let's look at the answers they gave us. Well, A is almost right. There's something wrong with A, though. That's not the answer. What's missing? The minus, I agree. B, nowhere near. I don't know what they did there. C, no. Hey, there it is. Which response is it? D. So you select response D. Any questions there? I think we need to switch back to my paper. We need to practice reducing fractions of this form where you have a plus minus square root. Now, the approach we're going to use to separate these, to reduce these fractions depends on whether you have an I or not. Question.
How could these plus and a minus get good and help in that fraction and people only solve the problem?
I'm not sure I heard your question.
How could a plus and a minus sign could fit into the answer problem even when we solve the problem?
Because we had two solutions. 2 plus the square root of 23 all over 3. The second solution is 2 minus. That plus or minus is just making it easy for us so we don't have to type in the two separate
I think it's going to
answers.
simplify. Why don't you plug it in, plug one of them in, and it's going to simplify really nicely. And check it the old-fashioned way.
Oh, okay. So we take the 3, plug in the 2 plus the square root of 23 all over 3 minus 2. That squared is equal to 23. The 3's cancel. So all you have is 2 plus the square root of 23. And what else do you still have there? You have the 2 plus the square root of 23 minus 2. Quantity squared equals 23. What's about to disappear inside those parentheses? 2 minus 2. So all you have is the square root of 23 remaining in those parentheses. And you're squaring it. Does that equal 23?
What did we say on day one about
What happens when you square a square root? What impact does a square have on a square root? And we said that's a concept that's going to follow us all semester long. They cancel each other out, so all you're left with is 23 equals 23.
And if you had put a minus here,
Then the negative would have been squared to still give you a positive 23.
Mhm. Any questions there?
We need to practice reducing fractions of this form where there's a plus minus on top and just a number on the bottom. Depending on whether you have an I, that will affect how the approach you take for reducing. And I made up an example for us just to practice with. I'm going to say reduce. I have two fractions here. I have 12 plus or minus 14 I square roots of 6 all over 4. Notice we have an I on the top here in this one. I want to compare that to 12 plus or minus 14 square roots of 6 all over 4. The only difference is we have an I in the first one, but not in the second one. I remember looking at this stuff in the second assignment, but it was just a plus or a minus. You'd have a number plus or a minus an imaginary number over an integer. And what we would do then, if there's an I, they're going to want their answer in the form A plus or minus BI. I remember that standard form for complex numbers. So if you have an I on top, you're going to have to split up, put the 12 over the 4, put the 14I squared roots of 6 over 4. So you have 12 over 4 plus or minus 14I squared roots of 6 over 4. Then you can reduce the fractions individually. If there's an I on top, reduce to two separate fractions. 12 divided by 4, I can reduce to 3 plus or minus. You can only cancel the thing under the radical, the thing that's not under the radical with the other number that's not under the radical. You can't say I'm going to cancel a 2 with the 6 and the 4. You can only reduce the numbers that are not under the radical. So looking at 14 over 4. 14 over 4, they're both divisible by what? 14 and 4. 2. So 14 divided by 2 gives me a 7. I square roots of 6. 4 divided by 2 gives me a... I know, and I'm waiting for him to say it.
4 divided by 2 is 2.
Here's how they'd want you to type in your answer. If you had solved an equation and gotten a fraction with an I on top, they want you to split up and cancel any common factors. Now, suppose there isn't an I. If there isn't an I, you look at the three numbers that are not under the radical. You look at the coefficient of the radical, the real part, the integer part, and the denominator. 14, 12, and 4. What's the biggest number that divides evenly into 14, 12, and 4? 1 divides in evenly, but that doesn't do anything. There's another number that divides evenly into 14, 12, and 4. 2. So I'm going to take out a 2 from the top. I'm factoring out a common factor of 2. 12 divided by 2 gives me 6 plus or minus. 14 divided by 2 gives me 7 square roots of 6. And I still have that 4 down there. If you don't have an I on top, you're not going to split up and cancel the way we do with an I. You factor out a common factor, and then you go 2 goes into 4 2 times. So your answer is going to be a single fraction. 2 is on the bottom. All that other stuff is on top. 6 plus or minus 7 square roots of 6. And that's going to be important.
As
How?
you do more and more of these, you'll probably skip this step and just say, okay, 12, 14, 4, divide each of those by 2.
You can say
12.
12 divided by 2 is 6. 14 divided by 2 is 7. 4 divided by 2 is 2. If there's an I on top, separate and cancel individually. If there is no I on top, you look at the 3 numbers outside of the radical, 14, 12, and 4. What's the biggest number that divides evenly into those? And that's what you divide through by. Look at this previous problem here. Look at this one.
Yeah.
There was no I, so we didn't split up. Why did we stop there? What are the 3 numbers that are outside of the radical? I don't see a number here. If you don't see a coefficient, what coefficient do you assume you have? A 1? That's like a 1 times the square root of 23. 1, 2, and 3. What's the only number that divides evenly into 1, 2, and 3? 1 dividing by 1 wouldn't change anything. 2 divided by 1 would stay a 2. 3 divided by 1 would stay a 3. That's why we didn't have to reduce any further there. Any questions? And as we go through solving the messier equations, this is the method I'll be using. When there's an I, split up, cancel individually. When there's no I, factor out the common factor from the top, cancel it in the bottom. And with that in mind, number 7.
I hope you haven't gotten logged out.
Number 7.
After all that talk, I don't think that there's a
Oh, we're not even going to have
here.
a fraction here, are we? Well, that happens.
Oh, Z's become 2's.
No, not for me, I know. Is it a Z plus 6 quantity squared equals a negative 10? Okay. I claim this problem is tailor-made for the square root method. We have a quantity being squared on the left. We have a number by itself on the right. It's tailor-made. It's already set up the way we need it. So we drop the square. That'll just give us a Z plus 6 equals, what are we going to have to pick up on the right? We drop the square on the left. We pick up a plus or minus the square root of a negative 10. I'm looking at that square root of negative 10. What am I going to have to do to that?
Make it imaginary.
Okay, because of that that negative under the square root, I'm going to bring out the imaginary unit I. So we have Z plus 6 is equal to a plus or minus that negative right there is what's becoming the I. What do I do with the 10? Can I reduce the square root of 10?
Is there any perfect square that divides evenly into 10?
Other than 1?
4,
9, 16. No? We'll just leave the 10 under the square root then. But we're not through solving the problem. We need Z by itself. What do we do to get Z by itself? Minus the 6. And remember, put it in front of the plus minus. So you'll have Z equals. That plus 6, when you move it over, it becomes a negative 6 plus or minus I square roots of 10 for my final answer. Any questions there?
Oh.
Oh, no, there wasn't even a fraction for us to reduce, but there will be. Somewhere on the way today, I'm sure there will be a fraction that'll be like that we'll have to reduce using these two techniques. It's another multiple choice. There's only three possibilities. Notice something. If there's only three possibilities and it's multiple choice, you only have one shot to select the correct answer. If it's a multiple choice with 4 or more possible answers, you get 2 opportunities. But if there's 3 or fewer possible answers, you only have one shot to select the correct
answer. Get
answer.
it wrong,
Then you got to say similar question and redo it to get credit. A, B, or C.
This gives you an idea of what this was like 20 years ago. When they first started this math, it wasn't Pearson, it was Addison Wesley.
Wow, I hadn't thought of Addison Wesley in a long time.
Okay, so
are
you ready
any
to
questions
do Roman
there?
numeral 3?
Okay, so we've done factoring, we've done the square root method, third method, the quadratic formula. So Roman numeral 3. The quadratic formula.
If I can speak for a moment, we've saw factoring, and we know that we can't factor every polynomial. Sometimes they'll be prime. Also, we've seen the square root method. That only works if it's something squared equals a number. So here we need a method that'll always work, and that's what he's about to do.
Solutions of the quadratic equation ax squared plus bx plus c. Solutions of a quadratic equation ax squared plus bx plus c is equal to 0 are given by, here's the formula, x equals, it's a fraction, on top we have the opposite of b plus or minus the square root of b squared minus 4ac. On the bottom, we have 2 times a. Now realize a is the number in front of x squared, b is the number that's in front of x, and c is the constant. Just like with factoring, you need the equation in descending order on one side and 0 on the other side. Realize you have to have an x squared term. If you don't have an x squared term, a would be 0, and you wouldn't have a quadratic equation then.
What do we call an equation that doesn't have an x squared, just an x? Starts with L. I asked him this on Wednesday. Linear.
Linear, but so these are quadratic. That means you have to have an a value. Now, before I use this equation, I want my a value to be positive, a greater than 0. If I had my a value, if it turns out to be negative, I'm going to pick it up and move everything over to the other side so that that a value becomes positive. It's just desirable to always have the a value be positive, because 2 times a, if a were negative, you'd wind up with a negative number in the denominator, and that would require more reduction, okay? So just follow my advice. Always make sure that the a value is positive, and you'll see how we do that when it isn't positive as we move through this these examples. Let's do number 8. It says solve using the quadratic formula.
Hey Tim, do you think you could do
Y
this by
squared
factoring?
minus 14y. If it's factorable, I could without being immodest. I'm
Yeah.
pretty good at it. I'm
But
pretty good at factoring.
The thing is, sometimes students say, well, wait, could I just do this by factoring?
What I've learned is if Pearson My Lab says solve using the quadratic formula, if they say that in the instructions, they're being nice. They're telling you don't waste an hour trying to factor it. It's not factorable. The quadratic formula works for factorable equations, but when they say solve using the quadratic formula, they're saying it's not factorable. Don't bother wasting your time. Switch to my paper. If I'm going to use the quadratic formula, I need reduced form on one side and descending order on one side and 0 on the other. Well, I don't have a 0 on the right-hand side. I will pick this negative 32 up, move it to the other side. That'll give me y squared minus 14y. What am I going to have here? What am I about to write? A positive 32 is equal to 0. You'll need to move the terms around. If you're going to use the quadratic formula, you're going to have to move the terms around in a way so that you have descending order on one side, 0 on the other. Now, if I'd had a negative y squared, say I had a negative 1 in front of that y squared, I wouldn't have moved the 32 to the left. I would have picked these terms up and moved them to the right. Remember, you want the coefficient of y squared to be positive. I don't even see a coefficient for y squared. What's the assumed coefficient sitting right there? 1. Let's identify. A is equal to 1. What about B? B is the number in front of the unsquared variable. What's B in this case? Negative 14. Be sure to take that sign. That minus sign is saying that the coefficient of y is a negative 14. What's my constant? What does C equal? 32. Remembering the quadratic formula, I just want to have something written right there that I can be pointing at.
Whenever you use the quadratic formula, you write it down. That's a good idea if you write it, copy it down every time you do a problem, you'll have it memorized by the time you're through with this assignment. You don't want to have to rely too much on a note card or something. Okay, I'll be quiet.
Okay. This first term, negative b, that's saying the opposite of negative 14. What's the opposite of negative 14? Think about that double negative property. Negative 14 becomes what? A positive 14. So this first term, that negative b, is just saying change the sign on b. Now b squared.
Oh, I have a calculator.
I would encourage you to use a calculator for that. So we want negative 14 times negative 14. Stop and think, negative times negative. What sign do you expect to have here under these parentheses? Under the square root. Negative 14 times negative 14 is going to be what? A positive 196.
I wanted to show something.
We need to show you.
Negative 14.
Okay, if you're using a calculator.
Something wrong. It's not.
X, close it out.
Close? Oh, reset. Now. Okay. Negative 14 times negative 14. We know negative times negative is positive 196. If you do this.
Negative 14 and try using your calculator square button. You know you should get a positive 196, but does your calculator give you a positive answer?
Maybe theirs.
Maybe yours does. but not this one here, not the TI models.
You have to put it in parentheses.
You have to put it in parentheses. My advice to you, you know a negative squared is going to be positive, so don't even mess with that negative when you're punching it into the calculator. I knew negative times negative is positive. What's 14 times 14? I wrote down my 196. We're not finished, not near finished. We need a minus 4 times A times C. A, we said, was 1. C is a 32. Y'all following me? I'm just replacing the A and the C with 1 and 32. All over the denominator, 2 times A. We can do that in our head. 2 times, what am I going to put in place of A? 1. 2 times 1, what's that? What is that about to give me for a denominator? 2. Did y'all follow my logic there? 2 times A, 2 times 1 gave me 2. Well, 4 times 32, that's a 128. So we have 196 minus 128. Or you can punch it in if you don't trust my mental arithmetic. Look at that, 196 minus 4 times 1 times 32. Sure enough, that's a 128. 196 minus 28 gives me a 68. No,
196
6 minus 128 gives me a 68. So we have a 14 plus or minus the square root of 68 all over 2.
You know, I think we reduce stuff like this on day 2.
On day 2?
Right? Yeah, we did. We were using imaginary numbers. So
Mm.
here there's no imaginary number.
There's no imaginary number. But remember I said,
can square root of 68 be reduced? Who has one of those little Casio calculators that you just punch in square root 68 and it doesn't give you a decimal, it reduces it? What are they called, Casio?
FX, I think the 250 does it, but the Casio FX 300, is it F2S or something? That'll reduce it very nicely, but I don't need a calculator to do this. 68. 68 is not a perfect square, but
show them your.
I think 4 divides
square.
in evenly. Where's the perfect squares? Where are they?
Day 1.
On day 1, I think 4 divides evenly into 68. 68 divided by 4. Is that 17? Someone check my mental arithmetic.
We've already checked it.
Oh, I did?
No,
okay. I was about to say, I don't recall doing that, okay? So square root of 68, we're thinking of it as the square root of 4 times the square root of 17. We have a square root that we can reduce. It's not a perfect square, but 4 divides evenly into it. So we have 14 plus or minus. We have a 2 down here. What am I going to do with the square root of 4? That's going to become what? A 2. So that's becoming my red 2. I still have that prime number 17 sitting underneath there. Okay. I knew we were going to wind up with messy fractions to reduce eventually. That's why I stopped and looked at this stuff when I did. Okay. Does my answer have an I in it? No, no I. So we're going to use this method. Look at the 3 numbers outside of the radical. They're all divisible by what? 2, 14, and 2. They're all divisible by 2. So let's just divide all 3 numbers by 2. Divided by 2, divide by 2, divide by 2. 14 divided by 2 is 7. plus or minus 2 divided by 2 is 1 square root of 17, and 2 divided by 2 is another 1. Well, we don't show the denominators of 1. Here's what we would, there's my answer, 7 plus or minus the square root of 17. You know something? I know Tony likes just going divided, 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 but let's see. Maybe I should show you my thought process. We said 14, 2, and 2 are all divisible by 2.
Move it up.
If we factor out a 2, 14 divided by 2 is 7, plus or minus 2 divided by 2 is 1, square root of 17. Then you can cancel the 2's. I think I like this method better. It gets a little messy there, but still, I think I like it better. You're dividing, it shows what you're doing. You're dividing all 3 numbers by the same common factor. Any questions there?
So
What about the peanut gallery?
Oh.
One day we're going to sit over there, so just be ready. So, question?
So what is that, I didn't understand that how red showed 68 is square root and 17 is.
I can't.
Was it the 4 and 17?
I could hear. Repeat the question.
Well, what you're saying is that 60 is going to 4 and 17. I define this to be share and then
Oh,
it
yes,
goes
we're
down.
reducing that square root of 68 the way we did on day 1. Look at the list of perfect squares. 4 is the only one that divides evenly into 68. So the 4 times 17 gives you the 68, and the square root of 4 is that 2 right there. Okay? But that was the reducing like we did on day 1. When we look at the perfect squares, okay, what perfect square divides evenly into, in this case, 68? Any other questions?
I'm going to type in this answer before we get timed out.
Does that ever happen to y'all?
7 plus or minus the square root of 17. When y'all are on campus, y'all ever use the college's Wi-Fi? It's good.
So
I remember back when it used to be so good, but it is
what we're
very,
using right
that's
now.
what we're using right now.
Okay, what's next? 9?
9. Okay.
Okay.
Okay. And as a student, y'all ever go to that fancy library we have? I can't believe it. It's those little things like that that get me so excited. What the library looks like now. Do y'all ever go in there?
Yeah.
Yes,
It's
that's a
nice.
nice library. If you're stuck here, not stuck, but if you're on campus and you need a place, say you have a break between classes, that's a nice place to go sit and find a quiet place and work on your math homework. Of course, if you need help, you can go to the Math Learning Center.
But that's not in the library.
But that's not in the
Coles
library.
building.
That's in the Coles building. 2x squared minus 13x equals 1. Now, if these quadratic equations were factorable and you factored it, you'd get the same instructions.
Same answer.
And I mean the same answer. But if the instructions say use the quadratic formula, they're sort of telling you don't waste your time trying to factor it. So I think that's pretty nice of the Pearson programmers to do that. If I'm going to use the quadratic formula here, there's really only one correct first step. What is it?
To move the 1 on the
To
Move
move
the
that
1
1 over to the left-hand side. So we have 2x squared minus 13x minus 1 is equal to 0. Then I'd identify my A, B, and C values. A is 2, okay. B is negative 13, C,
-1.
negative 1. Remember the quadratic formula.
We had a coworker that seemed shocked. He was complaining that his students couldn't remember the quadratic formula, and we told him, look, tell him to write it down every time you use it. And you do the same thing. And you know what he said? I can't write it down every time I use it. And we're like, well, why not? We do it. Do you remember
Yeah,
that
I know
conversation?
I remember. The person doesn't work here anymore.
Yeah.
Oh, they worked here?
Oh, yeah.
It was someone that worked here, but they don't work here anymore.
Okay. Negative B. The opposite of B. I mean, why couldn't they rewrite it?
Every time
Every time they're
do it in
using it
class.
today, every time I use it today, I'm going to write that thing down. Why? Because I want something to point at. Okay, negative B. What's that saying to do to that negative 13? Okay, make it a positive 13. B squared. Negative 13 times negative 13. Negative times negative is positive. 13 times 13 is 169. So negative 13 squared is 169. Minus 4 times A times C. A is, what am I going to write here? 2C negative 1 all over, what's my denominator going to be? The first one, it was just a 2. Is my denominator going to be a 2 right now? 2 times, what are we going to have to multiply the 2 by?
2.
2 times 2, so I now have a new denominator of 4. 2 times A. 2 times 2 gave me a denominator of 4. That's 169 plus 8. 169, that negative 4 times 2 times negative 1 is a plus 8. So 169 plus 8, is that a 177? How many? I'm sure most of y'all would punch that into your calculator. Tony, punch it into the calculator. 160. Okay, you see what he did? 169 minus 4 times 2 times negative 1. And sure enough, that ended up with the 177, which is what I said. And 4. You know something? What I've discovered throughout the years of using Pearson MyLab, if you wind up with some really odd, strange number popping up under a square root, odds favor it's not going to be reducible. 177 is definitely not a perfect square, but I don't believe there's a perfect square that divides evenly into it. 177, 3 isn't a perfect square, but see what you get if you go 177 divided by 3. Oh, watch it be reducible. Watch a 9 go in evenly.
Oh,
look at that. 177 is 3 times 59. 3 is a prime number. 59 is a prime number. And so there's no way you're going to reduce the square root of 177. So
what I was going to do was just fly through all the things, starting
he's going through
81.
He started at 81
yeah,
and he's
like
going through.
Logic.
That means there's not going to be a 1 here, a coefficient other than assume 1 in front of that square root. Am I going to have an I in my final answer? Am I going to have to type an I in my final answer? No, because that number's positive. If you don't have a number there in front of that radical, then remember to do that this method of reduction, since we don't have an I, to do that method of reduction, you have to have a number in front of that square root. If you don't have a number there, 1 13 and 4, the only thing that divides evenly is 1. You cannot reduce it any further. There it is. If you don't have a number in front of that square root, you are not going to be able to factor and cancel. You just stop there. Even if this 13 had been something like a 12, well, 4 goes evenly into 12. The fact that there's not a number there, you can't factor and cancel, just leave it. Any questions there?
Okay, look how I'll type it.
Okay, look at what he's going to do first. Now, I'll use that little slash periodically if I'm typing like a number over a number. But if you're typing a fraction that has other stuff other than just number over number, I highly recommend you use that fraction hot button. And that's what he did. He used the fraction hot button, 13 plus minus the square root of 177. And on the bottom, we have a 4. Any questions there? I want to do number 12. 10 and 11 are real similar. Number 12, I'm not sure why I like number 12. Why do I like it better than 10 and 11? Oh, I see why, okay. I thought it said x squared minus 8x equals 25. It says x squared equals 8x minus 25. Okay. X squared is equal to 8x minus 25. I need the equation with the 0 on one side and reduced form on the other.
Descending order.
Descending order. Why do I keep saying reduced form? Okay. When I look at this x squared, the coefficient is an assumed positive 1. Don't decide. I'm just going to move the x squared term over to the right, because if you do, then you're going to have a negative in front of that x squared. Remember I said, it's true for factoring also. You want that a value to be positive. So I'm going to pick up both of these terms on the right and move them over to the left. That'll give me an x squared. What else am I going to have here?
Negative x squared, or negative 8x.
Correct. And?
Positive 25.
Positive 25 equals 0. Any questions on my logic there? Eventually we'll see one where there's a negative number in front of that x squared, and I'll move everything over to the right to get rid of it. It hasn't happened yet, but it's going to happen eventually. But you move the terms around in a way so that you get 0 on one side and the leading coefficient is positive on the other. Yes.
In this problem, you move the terms around in order to get equals to 0.
Yes, it got to always be equal to 0.
But we did the same thing with this one. We had to get this one. We had to move the terms around. We had to move that positive 1 to the left to get a 0 there on the other side. You've got to have one side equal to 0. Move the terms around however you have to get that one side with 0, descending order on the other side.
And it doesn't matter if it's factoring or
the quadratic formula. You still need it in that order. What's my a value? Not x squared, it's the number in front of x squared, which is 1, okay.
A, B, and C have to be numbers.
B, negative 8, I agree. C, okay, and now we're going to write the quadratic formula down. Who knows, maybe eventually my fingers will get so arthritic that I won't be able to write this thing down every time I use it, but until then I'm going to write it down every time. I think it's a good learning tool. negative b. It seems like every b we've used today has been negative, and then we made it negative again, so it became what? Positive. There will be, eventually there'll be some positive b's, so when you make it negative, you'll have a negative sign in front. But as it is, the opposite of negative 8 is a positive 8. B squared. Negative 8 times negative 8 gives me a, well, I know negative times negative is positive, and 8 times 8 is 64. Negative 8 squared. Negative 8 times negative 8 gives me that positive 64. Minus 4 times A times C. Oh, I see why I liked this problem. Why I wanted to do it. What's my A value? What am I going to put here? 1. And here? 25. What about 2 times A? What are we going to have as our denominator? 2 times 1 gives me a 2. I agree. Oh, I better start writing smaller. I'm going to run out of room. We have 8 plus or minus. Well, that minus 4 times 1 times 25 is a minus 100. 64 minus 100, I'm getting a negative 36. Tony, what did that calculator of yours give you?
Negative 36.
Okay. Hey, 36 is a perfect square. That's nice. But what are we going to have to do? Or is there something else we're going to have to do there with that radical? You're going to pick up an I because of that negative sign there. So you're going to have 8 plus or minus. Because of that negative, you're going to have an I. This is really nice, though. The square root of 36 is 6. So we'll write it as 6i over 2.
8 plus or minus 6i.
8 plus or minus 6i over 2. There's an I on top, so what do? And you have a fraction involving plus minus with an I on top. You split up to give you 8 over 2 plus or minus 6i over 2.
Oh, wow, this reduces nicely.
I know, it does. 8 over 2 is going to reduce to 4 plus or minus here. 6 divided by 2 is 3. Don't forget your I for my final answer. 4 plus or minus 3i.
4 plus or minus 3i.
Give them a moment. They're still writing. Okay.
Let me type it in.
Okay, type it in.
4
Plus or minus.
plus or minus 3i. You'll notice a lot of times they'll talk about expressing complex numbers in terms of I, even when there isn't an I in the answer. Wasn't that,
They do that just to confuse you, but they're not going to. You're not going to get confused.
On number 9, it talked about to use I, but there were no imaginary numbers. Okay? It just means if there are, then.
Number 14.
14?
Yes.
Okay, at last.
Okay. Number 14. Negative 3, is that R or X squared? Okay. Is equal to negative 11x plus 13 Negative 3x squared equals a negative 11x plus 13. Okay, switch to my paper. The fact that they're telling me to solve using the quadratic formula means that is telling me that it's not factorable. But even if it were factorable, you could still use the quadratic formula, okay? And I'd get this thing set equal to 0. Let me ask you, if y'all been listening closely, you'll know what I'm going to do. I need 0 on one side. I need descending order with a positive leading coefficient on the other side. So with that in mind, what can I do so that I have 0 on one side by itself, either the left or right? It doesn't have to always be the right side where you get 0, and a positive leading coefficient on the other side. What should I do? Correct. Pick this one up. I don't want to leave that negative 3x squared where it is, because I don't want the x squared coefficient to be negative. That leads to all sorts of complications when it comes to reducing. So pick this up, move it over. So you're going to have a 0 on the left side. That negative 3x squared becomes a positive 3x squared. We still have a minus 11x plus 13. Any questions there?
Don't let the fact that 0's on the left worry you. You don't really do anything with the
If you
0.
don't like that, if you're one of those people that just has a preconceived dislike for the zeros on the left, equality is reflexive. This is still red. 3x squared minus 11x plus 13 equals 0. But if you don't like that, just mark it out and put the equals 0 there. It's the same thing. You see? There. It's the same thing. So if you dislike, but I don't have these preconceived prejudices. It was fine the way it was written for me, but just for this first one, in case you don't like the 0 on the left side, that's what you do. Just mark it out and put the 0 over there. Now identify A, B, and C. A is equal to 3. That's a positive 3. B is equal to, be careful, a negative 11. Good. And C, 13. Recall the quadratic formula. I'm going to write it down. Negative b plus minus the square root of b squared minus 4ac all over 2a the opposite of b. Negative 11 becomes a positive 11. B squared. Negative 11 squared. Negative times negative is positive. 11 times 11 is 121 minus 4 times A times C. And I want to go back to this 121 once more. You'd probably be surprised how many students have problems and get the answers wrong, and they're emailing me. And the problem is that they're punching in negative 11 squared incorrectly, getting a negative 121. So once again, my advice, just remember, if the b is, whether it's positive or negative, when you square it, it's going to be positive. So just ignore the negative. Square the 11. 11 times 11 gives us a 121. Okay, what's going to go here? A and C. Okay, all over 2 times A. What are we going to have for our denominator? 2 times 3 gives me a denominator of 6. Any questions on where I got that denominator of 6? 2 times A, 2 times 3 gives me a positive 6. Any questions there? So we have a 121 minus a 12 times 13, and 13 times 13 is 169. We could take away, oh, well, how about Tony punch it in? What's he getting?
A negative 35.
A negative 35. I didn't
Under-
see that comment. Well, yeah, it is, isn't
Yeah.
it?
12
Okay.
times 12 is 134. 12
Plus
times
another
13, yeah, 156. So
Okay.
121 minus 156.
Is a negative 35.
35.
I messed up. Hold on. That's a green 11. Plus or minus the square root of, what did you say, negative 35?
Mm-hmm.
All over 6. Is 35 a perfect square? Is there a perfect square that divides evenly into 35 other than 1? Think of the prime factorization. What times what equals 35? Other than 1 times 35, there's only one other pair. 5 times 7, those are prime numbers. You're not going to be able to reduce the square root of 5 with the square root of 7. So 35 is going to stay as is. But there's something else we have to do with this last term. What is it? Okay, that negative there, we need a positive 35 under the radical. So what are we going to do to get rid of that negative there? We're going to have to pick up something new. What is it? Not really new, but what are we going to have to pick up? An I. I agree. That negative, we have to bring it out as an I. We still have the 35 under the radical, the 11 and the 6. If you type this in as your answer, though, I bet you they're going to count it wrong. If you have a fraction of this type with an I on top, what are you going to have to do? Okay, so we're splitting it up. 11 over 6.
Even though you're not going to be able to reduce it.
You're not going to be able to reduce anything further. Excuse me. You're still, they want it in the form real number plus or minus imaginary number. Here's the real number. There's no I. Plus or minus. Here's the imaginary number. It has that I on there.
I think last semester, if you look at the video, for this problem, I typed it in like this,
Like what?
and it said wrong.
It did.
Okay, you gotta split it up. So let's see.
Well, they'd have to go and find the video from last semester, looking at the
It's called, it's the fall,
the
Spring
Spring
2025
2025 playlist.
11 over 6.
Get out of that denominator using the right arrow and then plus minus.
I'm gonna go ahead and do that.
I square root of 35
35.
all over 6. Any questions there? Before we do number 15, I have one more that I want to do, and then Tony's going to do number 15. I'm going to let him finish up, okay?
The 15's the last one,
Whoops.
so it's gonna be the hardest.
Yeah, you're
Okay.
right. Number 15.
Oh.
No, I'm not doing number 15. I'm going to do, I have an example I want us to do. Solve, I will, by the quadratic formula. Okay, it's a negative 4x squared.
Oh, do you see?
Oh, it is. Okay, you're right. Negative 4x squared is equal to 47x plus 99. It turns out this problem is factorable. This is a factorable problem.
But
I'm afraid that if you ran into something like this, it'd take you an awful long time to figure out the factorization. So if it's, even if it's factorable, the quadratic formula will work. That's what I want to show you. I need an a squared that's positive, and I need a 0 on one side. So with that in mind, what do you think I'm going to do? Okay, move that negative 4x squared. When you move it over, it becomes a positive 4x squared plus 47x plus 99 is equal to 0. Let's identify A, B, and C. A is equal to, what's A? 4. B, 47. C, 99. Don't forget that quadratic formula.
Oh,
Okay. Do you have your calculator out? This is going to get a little messy. Negative B. B is 47, so what's the opposite of 47? What am I going to write here? Negative 47. You see, I told you eventually you'd see a positive B value. If the B value is positive, then negative B becomes negative. Now, 47 squared. 47 times 47. That might, maybe, yeah, punch that into your calculator. That is going to give me 2,209. 2,209. Any questions on where I'm getting that B squared? 47 times 47 is 2,209 minus 4 times A times C. A is 4. C, what am I going to write here? 99. All over, what's my denominator going to be? 2 times A. 2 times 4 gives me, what, 8? Well, that's going to be a minus 16 times 99. How about we use we use the calculator.
625.
Okay, so we have a negative. We have a negative 47 plus or minus 2,209 minus 4 times 19. What did you say gives
99
me?
times 99.
99 gives me 625. That's nice. All over, we still have that 8. This is what's happening here in this problem is the first time it's happened in this class. We use the quadratic formula and we have a perfect square under the square root. If you use the quadratic formula and you get a perfect square under there, that tells you that it was factorable. It was factorable. We could have solved this by factoring, okay?
But no imaginary number.
But no imaginary number.
Negative 36.
But there's no imaginary number. The square root of 625 is 25. So you have.
So we're showing you how this differs if it's something that's factorable. You didn't need that square root symbol.
Oh, I don't need the square root symbol. So that equals. Okay, mark out all that stuff. So we have a negative 47 plus or minus. The square root of 625 is 25. If you punch it into your calculator, you'll see that the square root of 625 is 25, and we still have an 8. And there'll be people typing this stuff in here with a plus minus, and my lab will be telling them the answer is wrong. If you don't have a radical appearing there, then that means it was possible, it was a perfect square, you could have solved by factoring. You have to split it up into the two cases. We have a negative 47 plus 25. So a negative 47 plus 25 all over 8. Negative 27 plus 25, that's a negative 22 all over 8. Hey, what can we cancel? There's a common factor here. What can we cancel above and below? 22 and 8 are both divisible by 2. So we'll divide by 2, divide by 2, divide by 2, divide by 2 to give us a negative 11 over 4. There's my first answer. Now we have to look at the second possibility, negative 47 minus 25. Negative 47 minus 25 all over 8. Negative 27 minus 45, is that a negative 72?
Mhm.
Divided by 8, that gives me a negative 9 for my second solution. This thing was factorable. It would have factored as, let's see, x plus 9 times a 4x plus 11. If we had factored 4x squared plus 47x plus 99, it would have factored like that. Set this thing equal to 0, it'd give you a negative 9. Set that equal to 0 to give us a negative 11 over 4. Just realize, if it says to solve by factoring and you get something really messy, you can always use the quadratic formula to get the final solutions to the equation. But if you do, if it's factorable, you cannot leave the plus minus in the answer. You have to break it up as that number plus this number and that number minus this number to reduce and get your two final solutions. Any questions there?
This
Okay,
is one you just made up.
This
so
is just one I made up, so
now
okay, here,
oh, I have mine.
Oh, okay. Talk fast, that battery's nearly dead.
No, I got new batteries.
Oh, you
That's
got
why
new
I
batteries?
left, remember?
Oh, I
At
thought
the
you were
beginning
going
of
to make it.
class.
Oh, yeah, that's what.
Okay.
Number 15 is the last one, so it's got to be the hardest. What do y'all think? Does it look like the hardest? What's different about 15 versus all the others?
Look at 14.
Is there anything different in the problem? Looking at 14 and 15? Y'all got to see it.
They're going to ignore it and hope it goes away.
It's fractions, okay?
Yeah.
So the way it's written, 0 is by itself on one side.
A is equal to 1/2, B is 1/4, C is
1/14.
1/14, correct. And C is negative 1.
So you could just jump right into,
That's what I did with Mrs. Clark when I was in my Algebra 2 class. I just used the fractions. I didn't have a problem reducing those complex fractions, but I want to review something. What I prefer to do on problem 15 is to get rid of those fractions first. There's a way to remove fractions from equations. There has to be something equals something to be able to do this, okay? But I know you need to. There.
I want to review something called cross-canceling when you multiply when you're multiplying fractions. For instance, just recall multiplying fractions. Example, if we had 3 over 4 times 12 over 5.
Yeah. one way you can multiply these, the official rule for multiplying fractions, A over B times C over D. If someone told you state the rule for multiplying fractions, it would just be A times C over B times D. That's the way it's formally defined. To multiply fractions, you multiply the numerators together, then you multiply the denominators together. We could just multiply and we get 36 over 20, but then we got to reduce this. With cross-canceling, you look at the diagonals, 3 and 5, nothing but 1 goes into those. But here, 4 and 12. 4 goes into 12 3 times. So I'm dividing each of these numbers here by 4. 12 divided by 4 is 3. 4 divided by 4 is 1. Now multiplying straight across. On top, 3 times 3 is 9. On the bottom, 1 times 5 is 5. And that would have been the same answer you would have gotten if you'd multiplied straight across and then reduced. What about multiplying a fraction and an integer? Suppose we had this. 5 over 7 times 14. 5 over 7 times 14. Well, we could sure think of that 14 as 14 over 1. And can we do the cross-canceling? Rather than multiplying straight across, I like to do the cross-canceling. What can I cross-cancel?
7 and 14.
With 7 and 14, divide both of these numbers by 7, and we'd have a 1 down there, and what would we have up here? To give me what? What would the answer be? 5 over 7 times 14 over 1. Dividing both of these by 7, we're going to have a 5 times 2. Is this just going to turn out to be a 10?
Yes.
You can always, well, you can't, if it's possible, do a cross-canceling. If we had something like this, 133 over 24 times 48. So 133 over 24 times 48. Could y'all do cross-canceling on this? I don't think you want to multiply straight across here because those numbers are going to get pretty big. But what about right here? I think of that as 48 over 1. 24 goes into 48 how many times? 2. So I could divide both of those numbers by by 24. So I just have a 2 up here, and down here just a 1, so all my denominators are gone. 133 times 2. You want to help me out? That's going to be what, a 266? When you're solving equations, you can always multiply both sides by any number you want, except for 0. If you multiplied an equation by 0, then all you're going to get is 0 equals 0. Why am I mentioning that? Like right here on number 15, I would prefer not to have A equals a half, B equals 1 over 14, C equals -1. There's no reason why you couldn't do it like that. But here's what I'm going to do. I'm going to multiply straight through by a number of my choosing that'll cancel or cross-cancel with both the 2 and the 14. So I'm going to write down number 15, spreading it out. Okay? By that I mean I'm going to need some room to stick in a number. 1/2 x squared plus
1 over 14x minus 1 equals 0. Plus 1 over, okay, show them how I've written it out. What I want to do is
Notice how it's spread out. He has them written, the terms written like that for a reason.
I'm going to multiply straight through every term, even the 0, by a number that'll cross cancel both of these denominators. For instance, if I multiplied straight through by 2, the 2 would cross cancel with this 2, and I'd no longer have a fraction. But if I multiplied over here by 2, would it completely cancel out this denominator? If I multiplied by 2, this would give me a 7 here. So I still have that denominator. Can y'all tell me what number could I multiply straight through by that'll cross cancel with both the 2 and the 14? I'll give you a hint. It's not the 2.
It's called the least common denominator. When you're adding and subtracting fractions, you use the same number you would if you were adding and subtracting fractions trying to get a common denominator. The least common denominator would be 14.
Right there. If I multiplied straight through by 14. Now 14's the smallest number that'll work here. If you had multiplied by 28, would 28 cross cancel with both of these denominators? Yeah.
But then you're going to have more reduction at the end.
Because you have bigger numbers. So what am I going to get now when I multiply straight through by 14? 2 goes into 14 7 times. 7 times 1. Look at this. Isn't the equation already looking better? Instead of the 1/2 x squared, I have 7x squared. Then plus.
What's about to cancel here?
Are we going to have any fractions left?
The 14s cancel. And you're just 1 divided by 1, so that's just a 1x.
You can write the 1 or not. I think I'll write it just because we're going to be using the quadratic formula. So A is going to be 7. B is 1. I think that multiplying through by 14 is easier than saying A equals 1/2 and B equals 1 over 14.
Well, but we're not through rewriting the equation.
No, we're not.
What's the C value going to be? Realize you're distributing that 14 across both sides over all terms. So that 1 times 14 gives me a 14. Now it's nice on the right side. 0 times 14 stays a 0.
Is this problem in standard form to use the quadratic formula? Yeah. A would be 7. B is that 1 there. And C is negative 14. I'm just trying to cancel out those denominators. Now I'm going to rewrite the quadratic formula. I write it down every time I use it. Negative b plus minus the square root of b squared. This is nice because b squared we can do in our head. Minus 4ac. We don't need a calculator for b squared. All over 2a. So plugging in negative b. B was a positive 1, so what am I writing for negative b? Negative 1 plus minus the square root. Did y'all hear that? B squared, 1 squared is just a 1. Minus 4
7.
times A times C. So A is 7. I'm replacing the A with 7. I'm replacing the C with a negative 14. I think we'll want a calculator for that. All over 2 times A. What's going to be the number in the bottom here?
7.
Okay, so 2 times 7 is 14.
And a word of warning, look at how I punched that in. 1 minus 4 times A times C. I had a student last semester that was concerned because she didn't know, she had a different calculator, not one like I'm using, and she said she couldn't use her calculator because she didn't know how to use the parentheses. You don't have to use parentheses. You can type it in like this, 1 minus 4, those parentheses just mean times 7 times negative 14. So if you don't know how to use your parentheses on your calculator, then, or you don't see the parentheses, let's just use a times thing, times symbol.
We have negative 1 plus minus the square root of, what is that? 393. Ugh.
Y'all think 393 is a perfect square?
All over 14.
Certainly not.
Uh-huh. And
I don't think
really
it's
has one of
reducible.
those little Casio calculators where you punch in square root of 3.
Isn't that one right
It
there?
doesn't reduce, does it? Okay. So square root of 393, we're just going to have to leave it like that.
That's one of the things about my lab. If you come upon something, oh, look at that number, I don't know.
More than likely
it can't be reduced any further, okay? The programmers have taken all those things into consideration. Is there an I in the answer? So we can't split up, which means there's the final answer. There's no number that'll divide evenly into 1, 1, and 14 other than 1. Just write it as that single fraction there.
So the quadratic formula part of this problem wasn't really difficult. I just want to make sure y'all saw how I got rid of the fractions.
Because the next time on Wednesday, we're going to work with other equations containing fractions, and they're going to be messier than this, but we're going to use the same idea. What can we multiply through by to cross-cancel and cancel out those fractions? Okay. Oh, I better type in the answer.
I hope you have a good time down.
Okay. Okay, look at that. What do y'all think I'm going to type first? So type in that answer that we have. What am I going to type or click first? The fraction bar. Yes, I would not try to use the little slash from your keyboard. Fraction bar. Negative 1 plus minus. There's the square root of 393. Click down on the bottom to type 14. Any questions there?
Now, if at this point, if you have not done or an assignment is passed to you, the way Canvas lists them under passed due assignments, you might think, oh, well, that means I can't do it. No, you can. Just click on it and do it. Okay? For the homework.
Wait.
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 Do you want to stop and close the window? Say no.
No, but I do want to stop recording. Okay, is there any question that you want recorded before I stop the recording?